already what is the elective-B. It is a vector calculus we are having. So you know already core it is started and even completed the classes. Core is that it is a numerical methods, and elective A is a DMS, okay, discrete mathematics system, and elective B is about the differential calculus we have, okay, sorry, vector calculus. So already in the intermediate you have studied about what are the vectors and what are the scalars. Even in the 5th sem, you have the linear algebra is, in that you have the vector is there, okay. Vector space we have studied. In that also you know the concept of what are the vectors and what are the scalars and what are the conditions for finding the vector space. So if you know the concept of what are the vectors and scalars, so you can interlink them, whatever the concept you have in the intermediate, with the help of those some concept definitions are there. So what are the vectors, what are the scalars, and also what are some in the unit 1, even in the block 1, unit 1, you have the previous whatever the topics are there or definitions are there, depending on the vectors, all definitions are there. So if you know, go through those all definitions, then it will be easy for us to do the problems in the other blocks also, okay. So block 1 is about the main basic concept of the vectors, it is there, okay. So if you see, it is a vector calculus. It is also known as vector analysis. So we call the vector calculus as a vector analysis, which deals with the differentiation and integration of vector fields, okay. So here, whatever the calculus is there, vector calculus, we call even it as a vector analysis, which deals with the differentiation. You know the concept of what is the differentiation and what is the integration. So it deals with both of them with the help of the vector fields, especially, and whatever the vector calculus is there, we deal it in the 3-dimensional Euclidean space, okay. So we in intermediate, whatever the vector algebra you have studied, it is in the 2D, it is there, it is, that means 2-dimensional geometry. So in which you have the x-axis and y-axis. But in 3-dimensional geometry, that is a Euclidean space, we have the 3 axes, that is x-axis, y-axis, and also z-axis will be there. So one more definition is there for the vector calculus. It is the vector analysis is an analysis which deals with the quantities that have both. So it is also the analysis, means it is, if you know the definition of vectors, from that we know that vectors means which have both magnitude and direction. So such whatever the terms will be there, we call them as a vectors. That means which have both magnitude and also direction. So vector calculus deals with 2 integrals such as line integrals and surface integrals. So if you go through the content in the textbook, first whatever the 4 blocks are there, in that block each you have the each block you have 3 units are there. So in that, if you see, you will have the line integrals and also surface integrals are there, and also volume integrals are there. So almost in vector calculus we deal with these all concepts. So if you see the block 1, it is the vector differential calculus. So if you have textbooks, try to open them. So in the block 1, we have the 3 units are there. First one, unit 1 is the basic vector algebra, means whatever the basic concepts are there regarding of the vector algebra, that concepts are there in the unit 1, okay. In unit 2, it is a differentiation of vector point functions. So how we'll find the differentiation for the vector point function, whether it is a first order or second order or third order or nth order, how we'll find the differentiation of that one, that we have in unit 2. And third unit is about the gradient, divergence, curl operators. We'll have the 3 operators will be there. That is a gradient of a vector will be there. A gradient of a vector means we'll write it as a del. So del means reverse delta will be there, no, capital delta, that will represent gradient of a vector. Okay, gradient in the sense it is the del into pi. Okay, so next we have the divergence. Okay, del dot f will be there. Curl of a vector means f. Okay, so f is here, any function will be there. So that function, if you do pi means pi will be whatever the function is there, that function with the help of the del, if you find that one, then these three are important: gradient of a vector and also curl of a vector and also divergence of a vector. So on this, just if you know what is the definition of that one and how it is defined and how it is represented, if you know, it's enough for us. On this, you will get the problems for finding, you will ask to find the gradient of the vector or gradient of the function or divergence of the function or curl of the function. Okay. So that we have in the unit 3. So first one is about the introduction of vector algebra. Second one, we have the differentiation of some functions will be there. And third one is about the these three functions. That is a gradient of a function, divergence of a function, and also curl of a function. Okay. So this is about the block 1. So if you go to the block 2, so block 2 is about the multiple integrals. So multiple integrals means here we know only single integral. Only one integral means we know integration symbol is a one integral. So in this block 2, we will deal with the double integrals and also even the triple integrals. That is a we call it as a triple integral or we call it as a multiple integrals. Okay. So in integral calculus, you have studied about the only single integral. In vector calculus, we deal with the even with the single integral and also double integral and also triple integral. So that is about the block 2. We have we call it as a multiple integral. So unit 4 is transformations, polar, spherical, and cylindrical polar coordinates. So this is also unit 4 is very important one. So you will get one 5 marks question regarding of transform, whatever the transformation is there, the transformation will be either from polar coordinates to spherical coordinates or spherical coordinates to cylindrical coordinates. Depending on that, you will have the problems will be there. So unit 4 will study about the definitions of polar coordinates, spherical coordinates, and also cylindrical polar coordinates. Next, if you see the unit 5, it is a double integrals will be there. So any function will be given. That function you have to find the double integral by changing of order of integration. Okay. So that is about the unit 5. And if you see the unit 6, it is about the triple integrals. So function will be given and also limit points will be given. With the help of that, you have to find the triple integration for the given function. So so limits will be there for this one, triple integrals, and one function will be given. So on substituting the limits one by one, you have to find the value of the triple integration of the any function. Okay. So that is about the unit 6 in block 2. Next, if we go to the block 3, block 3 is about the vector integration. Okay. So in this, already just now I have told that vector analysis means even it deals with the two integrals. One integral is a line integral and another integral is a surface integral. So that whatever the definition is there, in unit 7 you have what are line integrals and what are the surface integrals. Okay. So definition is there on what are line integral definition is there and also surface integral definition is there and how we denote that one. And depending on that, you have problems are also there. Okay. Surface integral, how you define and how you represent that one. And also how you define the line integrals and how you represent the line integrals. So that you have in the unit 7. And unit 8 is about the volume integrals and application of vector integration. So volume integration means how you define the volume of a integrals. So we denote it with the help of triple integral will be there. That is with respect of v will be there f into dv. This is called as volume integral. So on volume integral also you have the problems are there. So on that applications of vector integration is also there. Okay. So if you know the concept of what is line integral, what is surface integral, and what is the volume integral, then whatever the block 4 is there, we use these concepts in block 4. Okay. So if you know the definition and how, what is the representation and how to find the problems, it will be useful for block 4. Okay. Unit 9 is about curvilinear coordinate cities based. So this is about block 3. Next, if we go to the block 4. So block 4 is very important one. So you know already that section C, whatever section C is there, that it is removed as a objective type and it is given as a one long question, no? That is 20 marks question is there. So in that you have the chance of getting these theorems. 3 theorems are there in the block 4. First theorem is the Green's theorem and its applications. So derivation and also statement. So question will be like the state and prove the Green's theorem, and one problem will be attached for that one for getting the 20 marks. Okay. Even if you go to the if you see the 10th unit, you have the Green's theorem is there. That is a derivation will be there, statement and also proof will be there. And on depending on this Green theorem, you will have the problems. So with the help of the Green's theorem, you have to prove the whatever the question given in that. With the help of the given function, you have to prove the Green's theorem. Okay. So if it is asked for 20 marks question, then proof will be there, statement will be there, and problem will be there. Okay. So similarly, if we go to the unit 11, you have the Stokes theorem is there. So Stokes theorem also, for these 3 theorems, even you have the diagram is there. So compulsory you have to draw the diagram also. Stokes theorem also, statement will be there and also proof will be there, and proving the Stokes theorem with the help of the given functions. So any function f will be given. So with the help of that, you have to prove the Stokes theorem. Okay. So that means whatever the statement of the Stokes theorem will be there, right hand side and left hand side. If we get both the same values, then we can say that it is proving the theorem. Okay. So this also you have the chance of getting for 20 marks question. Next, if you go to the unit 12, you have the Gauss divergence theorem is there. So Gauss divergence theorem, it is also same statement and also proof will be there, and its applications in finding the problems. Okay. If you know the statement of these 3 theorems, easily you can solve the problems. So these you will get even for 10 marks question in section B, and also you have the chance of getting for 20 marks question in the section C. Okay. So these 3 theorems are important. So this is about the 4 blocks and even the units. Okay. So if you go to the block 1, so you have the basic vector algebra. So in that, if you'll see first what is the definition of a vector. Vector means it is a quantity which have both magnitude and direction. So this is the definition regarding of the, if you see in the physics also, you have seen the vectors are there. So whatever the physical quantity will be there, if it has both magnitude and direction, we call it as a vectors. So direction, we know. Direction means like this, which has direction. So if you see this one point and one point here is there. This is the direction, and here if it is the point A and point B. Okay. So here it has a direction, it is showing some direction, and whatever it is traveling from point A to point B, whatever the length, we call the magnitude as a length. That means from point A to point B, whatever it is traveling the distance, that is called as a magnitude of the point. Okay. So if you see whatever this diagram we have, point A and point B, we represent the vector as like this. Okay. On the above, you will have the arrow mark. So we call it as a vector which has both direction and also magnitude. Magnitude is nothing but it is the length of that one line. Okay, line segment. Whatever the length of that line segment is there, that is called as a magnitude of that vector. Usually we represent the vector with the help of small a. That means whatever this is there, we represent with the a, and on the above, if it is there, it shows that it is a vector a. So vector a. So magnitude in the sense like this modulus. We find the modulus of this is called as a magnitude representation, or we call it as the length of the vector. Okay? It is a length of the vector or magnitude of the vector. This is the representation of the vector. Okay? So in mathematics, we define the vector as a directed line segment. Directed line segment. This is the line segment. No? So AB is the line segment which have some direction. It is showing some direction. So that's why vector in mathematics, almost we define it as a directed line segment which has some length here and which has some direction. Okay. And whatever the first point is there here, that point is called as initial point. And whatever the end point is there, that is point is called as terminal point. So first point is called as initial point and the end point is called as a terminal point. So here, whatever the definitions are there in the first unit that are important for even for other blocks also. So this is called as initial point. And this whatever it is called as terminal point. Okay. So magnitude of AB. Just now we have seen the magnitude of AB or length of AB. This line segment length or magnitude of AB is equals to, we'll write it as modulus, or magnitude we can call it as R length. Okay. Next, if you see co-initial vectors. So co-initial vectors means which have only one initial point. So whatever the vectors we have, if they have only one initial point, common initial point or same initial point, we call that vectors as co-initial vectors. This is vector A and this is vector B. So these are called as co-initial vectors. Okay. So these are definitions you have in your textbook. Next, one more concept is there which is important, that is position vector. Position vector of a point. Okay. Position vector of a point P means, we know that if we are dealing with the three-dimensional geometry, no? So three-dimensional geometry means we have the figure like this. This is X, this is Y, and this is Z, and this is the origin. So you will have 0, 0, 0. Why? Because we have the three coordinates are there. So if you see one point in this, if you take the point P and if you join with the origin, so here whatever the point P is there, it has a coordinate X, Y, Z. Okay. So whatever the point is there, even you can represent whatever the distance from 0 to P is there, no? The distance as R, that is vector R. So this whatever position vector will be there, this position vector R is equals to Xi plus Yj plus Zk. So in solving the problems, we'll take that as a That is vector R is equals to xi plus yj plus zk. Okay. And magnitude of OP. Whatever this OP is there, that if you find the magnitude of this one, OP is equals to what is there? Vector R. So it is equals to, that is OP R. We can call it as R also. Magnitude of R. Okay. So magnitude of OP means what are the coordinates of O? 0, 0, 0 and P, X, Y, Z. So when we find the distance between O and P, that is P minus O. Okay. So we'll get it as it is equals to under root of x square plus y square plus z square. Okay. This is the way how to find the position vector of a point P in the three-dimensional vector. If it is a two-dimensional means we'll get it as x square plus y square under root of x square plus y square. Okay. So this is about the position vector of a point P. Next we have types of vectors are there. Means how many types of vectors. In that only you will get the first one is the equal vectors will be there. Equal vectors means if two vectors have the same direction and also same magnitude. If two vectors have the same direction and also magnitude, then we call it as an equal vector. So types of vectors. The first one is equal vectors. So equal vectors means which have same direction and magnitude. Same direction and magnitude. So whatever you have the direction, that is A, B is there. If you represent with vector A, so same magnitude it should have C and also D, and it may be vector B. So which have both direction is on right hand side we have, and also the magnitude is also same magnitude. What magnitude is nothing but the length. So such type of vectors are called as equal vectors. Okay. Next, if we go second one, it is a zero vector is there. Zero vector is very important in solving the problems, and also any theorems are there. There also we use we call it as a zero vector or null vector, or we call it as null vector. Okay. So zero vector means which has zero magnitude. Okay. So it may have whatever the here magnitude, the length is there, that is zero means wherever it is point is there, the point only we have the point A. Means it has a zero magnitude. So we call it as a zero vector. The direction, whatever the direction of the zero vector will be there, it is arbitrary. Means just we have to imagine that one. It is in this direction or it may have any direction. Okay. So such type of vector is called as a zero vector, and representation is very important for the null vector, that is zero like this will be there, or dark bold O will be there. So this is called as zero vector. So representation of vector and zero vector is important. Next we have the unit vector is there. Unit vector also very important in solving the theorems will be there, and also representation of the unit vector in solving the problems. It is very important. So unit vector means first thing is we represent the unit vector as unit vector is represented as A cap like this. So on the whatever the vector A is there, on that if you write the cap, it represents that it is a unit vector. So unit vector definition is that magnitude, whatever the magnitude of the vector, if you have it as 1 unit, if the magnitude is 1 unit, it is called as a unit vector. If A is a vector, then A by mod A is a vector with unit magnitude. This is unit vector in the direction of A and denoted by A cap. Usually you will represent like this one vector. It has some magnitude. So this is the vector A. So along the vector A, we have one more vector, that is A to the power of A to the cap. Okay. So this whatever A cap is there, it is moving along with whatever this is there. This has a magnitude as 1 unit. Okay. So whatever the vector here A cap is there, it has a magnitude 1 unit. It is moving along the direction of the vector A with the help of the magnitude 1 unit. Such type of vector is called as a unit vector. Okay. So that's why we define A cap as vector A by magnitude of vector A. Okay. A cap is, this definition is very important for solving the problems. Okay. A cap is equals to vector A by modulus, that is the magnitude of vector A. So any vector with magnitude 1 unit, it is moving along the direction of vector A. Such type of vector is called as a unit vector, and this representation of unit vector is very important for solving the problem. So unit vector is defined as, this is the definition of that one. And here, whatever the representation is there, that is A to the power of cap. So wherever in the problem or in any definition or in any theorem, if you see A to the power of cap, it represents that it is a unit vector. Okay. Next, if we go to the another definition of the vectors, next we have the negative vector is there. Negative of a vector. Negative of a vector means if A is a vector having same magnitude as A, so which has same magnitude but which has direction opposite. Such type of vector is called as a negative of a vector. Okay. So negative of a vector means same magnitude but having opposite direction. Okay. Which has the same magnitude but have the opposite direction. Such type of vectors are called as a negative of a vector. Okay. So you can see like this. Okay. This is the one vector, and if you see the another vector there, if you see this, we write it as minus A. So A is equals to AB minus A is equals to BA, which have the same magnitude but the direction will be different. So that type of vector is called as a negative of a vector. Next, if you see, you have the non-zero vector will be also there. Non-zero vector means a vector whose magnitude is not zero. So if it has magnitude as not equals to zero, it is called as a proper vector or non-zero vector. Okay. So magnitude of A equals to A, which is greater than zero. That is called as non-zero vector. Next, the important one is uh, coplanar and also collinear of vectors. So collinear and coplanar, you are familiar with the 3D also, three-dimensional geometry also. If you see, you have the collinear points will be there and also coplanar points will be there. So similarly, like that only, you will have the collinear vectors will be there and also coplanar vectors will be there. So depending on this, you will have the problems are there on collinear vectors and also coplanar vectors. So collinear vectors, if you see, one theorem is also there in page number 1.5.7. Collinear vectors means if the three vectors lie on the same plane, that is same line. So that is A, B, and C. Okay. So if their lines of support are either same or parallel, if A and B are collinear, then their direction are same or opposite. We know the collinear points. That means whatever the points are there, if they lie on the same line, then we call them as a collinear points. So similarly here, if you see the vectors, if they lie on the same line, then that vectors are called as collinear vectors. Collinear vectors means they lie on the same line. Co means same, linear means line, same line. If the vectors lie on the same line, then we call them as the collinear vectors. Next, another one is coplanar vectors. On this also, you will have the 5-mark problems will be there. So it will be asked in the section A. Show that the vectors are collinear or show that the vectors are coplanar. Coplanar vectors means coplanar means co means here same. These will be in the same plane. If the vectors lie in the same plane, then such type of vectors are called as a coplanar vectors. You will see this is one plane. Any plane surface. Here vector A is there, vector B is there. Okay. If they lie in the same plane, then we call those vectors as coplanar vectors. Coplanar vectors may be for 3 vectors also we will see, 4 vectors also we will see. So in some case for the 4 vectors, they may or they may not become the coplanar vectors. Coplanar in the sense, if they lie in the same plane. If A, B, one more is there, C, it is lying in the same plane. So one more vector is there, it is D, outside the plane. Okay, if it is lying outside the plane means it is not coplanar vector, only A, B, C. These three are the coplanar vectors, but A, B, C, D are non-coplanar vectors. Okay. So the main concept is that if it lie in the same plane, then we call it as a coplanar vectors. If they lie on the same line, then we call it as a collinear vectors. Only one line if they lie. Vector A, vector B, the distance between A, B, B, C, and if it is of the one is another vectors, it will see C. So that means if they lie on the same line, that vectors are called as collinear vectors. If they lie in the same plane, we call it as a coplanar vectors. So definition is there in the test book. It is a set of vectors which lie on the same plane or whose lines of support are parallel to the same plane. So on this also you have theorem is there. On collinear vectors also you have one theorem. And on coplanar vectors also you have theorem is there. On page number, that is the theorem number, it is 1.5.9. So A comma B comma C are coplanar if there exist scalars m and n such that vector C is equals to m into A plus n into B. This is the theorem you have in your textbook. So try to practice this one. Vector C is equals to m into A plus n into B. M and n are here scalars. Scalars are nothing but here real numbers. We take the real numbers as a scalars. And here A, B, C are the three vectors we have. So on coplanar of vectors, you have theorem is there in that is 1.5.9. So practice that one. So this is about the coplanar vectors. Next you have algebra of vectors is there. So algebra of vectors means first one is the addition of vectors. That is two vectors are there. How to add those two vectors? Sum of A vector A and vector B can be found by triangle law or parallelogram law. So this you have what is the triangle law of addition and what is the parallelogram law of addition. Vector addition you have in your textbook. So by that you can see how you can add the two vectors with the help of triangle law and also with the help of parallelogram law. Next in page 1.4.4, page number 10 and also page number 9, you have the properties of vector addition. This which properties vector addition is satisfying that you have. This is the important one. Properties of vector addition. So first property is satisfying, that is the commutative law. So in fourth semester, you have the algebra. In that you have seen what is a group, what is a ring. So to form a group or to form a ring, what properties it has to satisfy. In that you have seen what is a commutative law. Commutative law means A plus B is equals to B plus A. So here also vector A plus vector B is equals to vector B plus vector A. If it is satisfying this property, then we call that it is satisfying the commutative law. Okay. So next one is the associative law. Or we can call it as associative property. That is vector A plus vector B plus vector C is equals to vector A plus vector B plus vector C. Okay. This is the associative law. Next we have the subtraction of vectors is there. Subtraction of vectors. Vector A minus vector B is equals to vector A plus vector minus of B. So wherever we do the subtraction of vectors, we have to write in this form. Okay. So like this, we can find the vector subtraction of vectors. Next, multiplication of a vector by a scalar. Multiplication of a vector by scalar means this m is any scalar and a is any vector. So that is the multiplication of a vector by scalar. Next, collinear vectors. Collinear vectors will be in the form of like this. We have seen here collinear vectors. So to solve the problem, we'll write vector A is equals to some scalar k into b. So if it is satisfying this condition, then we call those vectors as a collinear vectors. Next, component of a vector. Component of a vector means So component of a vector A is equals to is magnitude of A equals to root of x square y square plus even we call it as a position of a vector, component of a vector or position of a vector. Okay. So we have seen what is the collinear vectors and also what are the coplanar vectors. So we'll see one problem to show that the 4 points, show that the 4 points 4i plus 5j plus k comma minus j minus k comma 3i plus 9j plus 4k and 4 into minus I plus j plus k are coplanar. Here 4 points are there. So we have to show that these 4 points are collinear, coplanar. Okay. That means they lie in the same plane. So this problem you have in a MEQ question. Okay, model examination questions will be there last after completion of the unit. So there you have this problem. Show that the points or show that the 4 points. Okay. Comma minus k 3x plus 9j 4 points 4i plus k and minus j minus k comma 3i plus 9j plus 4k and 4 into minus I plus j plus k are coplanar. That in the question it is given they are coplanar. Okay, that means coplanar means these 4 points lie on the same plane. And for finding the if, if 4 points are given or in some case they will give you the 3 points and they will ask you to find the coplanar. So the easy method is with the help of the determinant. If 3 points are there means directly you have to substitute in the determinant and you have to find the determinant of that. If you will get the value as 0, then the 3 points are coplanar. But here we have the 4 points are there. So these 4 points, we have to convert them into 3 points and then we have to substitute in the determinant and we have to find the value. Okay, if you find value of the determinant, if we get 0, then we call the 4 points are coplanar. Okay, so if 4 points are given means like this, they like if point A is there, then here it is B, then it is C here, then it is D, like this. Okay. So this is the vector A, this is vector B, and this is vector C. Like this. So here you can take let vector that is A is equals to 4i plus 5j plus k. Okay. B vector is equals to minus j minus k. C vector is equals to 3i plus 9j plus 4k. Now vector D is equals to 4. We can take it as minus 4i plus 4j plus 4k. If you multiply with 4, okay. So these are the whatever 4 points are there. The 4 points you are taking it as A, B, C, D. So if you represent here like this is the vector A. You have it is with the help of this we are taking it as we have to find AB, AC, and AD. These 4 points they lie in the same plane. Okay, coplanar in the sense they lie in the same plane. If it is asked in the question, it is show that they are non-coplanar means one point will be lying outside the plane. But here in the question itself, it is given it is coplanar means these all 3 points lie in the same plane. So here now, if you find AB, AC, and also AD, then you will, with the help of those three vectors, that means you are finding vector A, vector B, vector C. If you get those values and if you substitute in the determinant, then we can find the value. Okay. Let the 4 points here you write. For this, let the 4 points be A comma, B comma, C comma, D. Okay. So here A is this one, B, C, D. Okay. Now given A comma, B comma, C comma, D are coplanar. So it is given in the question. They are coplanar. So these are coplanar if that is A, B, A, C. So the triplet of AB, AC, AD, if it is equals to 0, then we represent that the 4 points are coplanar. Okay. So for this, first thing we have to find the vector, small vector A. What is small vector A? It is the AB. So AB is equals to, we'll write it as OB minus OA. So that means B minus A also we can write. So what is B minus J minus K and minus 4i minus 5j minus 5j minus k. Okay. So it is equals to minus 4i minus minus means minus 6j minus minus means minus 2. 4i minus 6j minus 2k. Next vector B is equals to AC. So AC is equals to, even we can write C minus A or OC minus OA, anything. Okay. 3i plus 9j plus 4k minus A. What is it? A is minus 4i minus 5j minus k. Okay. 3i minus 4i means minus I plus 9j means it is 4j plus 4k minus k means plus 3. Okay. Next, if it's C is equals to, vector C is equals to what is C? AD. So that is AD is equals to D minus A. Or else we can write this as OD minus OA also. OD minus OA means we call them it as position vectors. Okay. So C is equals to AD. What is D? D is minus 4i plus 4j plus 4k. Minus A. What is A? Minus 4i minus 5j minus k. So 4i minus 4i minus 8i is minus j plus 3k. Okay. So So now we got the three vectors, that is vector A, vector B, vector C. So here, so we can't write here. So up till here is this one. How to show that 3 points are there means directly determined we can find. But when we have the 4 points, we need to write like this. That is, whatever the point A is there, with the help of that, we are finding the three vectors A, B, small b, small c. And these 4 points, they lie in the same plane. So why? Because it is a coplanar. So with the help of that, whatever the given are there, the points are the A, B, C, D we have. So these whatever the points are there, with the help of that points, we are finding the vector A. It won't write here as a vector, just write as a points here. Okay. This is the point A, this is the point B, this is the point C, and this is the point D. Okay. So these whatever are there, with the help of them, we are finding vector A and vector B and vector C. So we got the A, B, C values. Now to show that they are coplanar, we have to find the determinant of this one. So triplet of this one is this vector A, vector B, vector C is equals to determinant of what is first vector A? -4, -6, -2. Next to -1, 4, 3. Next to -8, -1, 3. We have to find the determinant of this one. So that is -4 into 4 3s are 12 plus 3 minus of minus plus 6. So -3 plus 8 3s are 24 minus 2 into minus plus 8 4s are 30. So 15 4s are -60. This is 21. 21 into 6, 6 6 is 126 plus 126. 32 plus 1 is 33. 33 into 2. How much? 66. Minus 66. So this, if you add, you will get it as minus 126 plus 126. Okay, if you cancel out these two, you are getting it as 0. That means, so whatever the given 4 vectors are, they are coplanar. Therefore, 4 points are coplanar, or given 4 points. Therefore, given 4 points are coplanar. So if only 3 points are given and he is asking to find the coplanar directly, like this determinant you have to write. And if you get it as 0, then they are coplanar. If you get it as not equals to 0, then we call that they are non-coplanar. Non-coplanar in the sense, one vector will lie out of the plane. So whenever it is lying out of the plane, then we call it as a non-coplanar vectors. Okay. Even collinear vectors also, you have the problems are there. This is the MBQ question you have, whatever it is there. Next MBQ question 4 is there. That is to show that the given points are collinear. So if vector A, vector B, vector C are non-coplanar vectors, then show that the points -2A plus 3B plus 5C, A plus 2B plus 3C and 7A minus C are collinear. So collinear in the sense they lie on the same line. Okay, the given vectors lie on the same line. Further, we have to denote whatever the vectors given in the problem are there. No? You denote them as a position vectors OA, OB, and OC. So let us denote the given points as ABC and AB and B. We have to find AB, AC, or AB, BC. Anything you can find. If you will get any relation, just now we have seen no, if they are collinear vectors means if A is equals to K into B. K is any scalar here. So if you get the relation like this, then we call those two vectors as a collinear vectors. Okay. So this problem tomorrow we'll see that one. Okay. So collinear on collinear vectors also we do have the theorem is there and see the example problems 1.5.15. So that is also important one. You will get further 5 marks question and also 1.5.14. Those two example problems. So tomorrow we'll see the problem on collinear vectors.